In this video, I'm going to show you how to make a hypothesis. Once you've made your aim, the next step is to make a prediction about what the most likely outcome will be from your experiment. Now, this prediction doesn't have to be correct, okay? It just has to be testable, all right? It just needs to be testable. Now, there are kind of two ways for writing a hypothesis, and I'm going to show you both ways. Now, imagining that your independent variable is quantitative, that just means it has numbers. Okay, so if you are intentionally changing temperature, well, temperature has numbers. If you're intentionally changing distance, distance has numbers, okay? Anything that involves numbers is quantitative. So if your independent variable is quantitative, then you would use this formula, okay? As the independent variable increases or decreases, the dependent variable will increase or decrease. Okay, so you just choose and insert the correct parts into that formula. So if we have a look at the experiment below, so the experiment is the time it takes to run a mile depends on the person's running speed. Okay, and we worked out what the aim for that experiment could be. So the aim could be to investigate the effect of running speed on the time it takes to run a mile. How could I write a hypothesis for that? Well, I'm going to use the formula from above and insert the correct information as I go. So, as the independent variable, so in this case it's the running speed, so as the person's running speed, and now I've got to actually make a decision. Do I say it increases or do I say it decreases? Okay, I need to make a decision, right? This is my prediction. So I'm going to say as the person's running speed increases, the dependent variable, and in this case, the dependent variable is the time to run a mile. So the time it takes to run a mile. And now I've got to make another decision. Will I say that it increases or will it decrease? Okay. So this is where I need to make a prediction, right? And I'm thinking to myself and I'm saying, okay, well, as the person's running speed increases, the time it takes to run a mile, well, I think that the time will then decrease. So that's what I'm going to write down, okay? Now, does my hypothesis need to be correct? No. But it needs to be testable. Is this testable? Well, it is, because I can just change someone's running speed and then I can measure how long it takes for them to run a mile. So, is this testable? Yes, this is an appropriate hypothesis. Okay? The other way is if your independent variable is qualitative. And when it's qualitative, it doesn't involve numbers, it involves words. Okay, so if I was wanting to measure the color of something, well, a color is a word. If I was wanting to measure the type of liquid, well, the type of liquid is a word. Okay, so qualitative involves words. And that will use a slightly different formula, as it shows you below. So the insert your specific independent variable will insert some predicted outcome. Okay, so having a look at this experiment now, right, I'm changing the liquid to water a plant, and then I'm seeing how high it grows. Right, the aim to investigate the effect of the type of liquid used to water the plant on the height of the plant. Okay. So what would my hypothesis be? Okay, well, I'm going to start with my formula. Okay, the specific independent variable. Okay, so now in this case, I'm changing the type of liquid. Okay, that's what I'm intentionally changing. So I need to think to myself, right, what liquid, well, actually, before I start with the liquid, maybe the predicted outcome is easy to start with. Okay, well, in this experiment, what is a predictable outcome? Well, a predictable outcome will be which one grows the tallest. Okay, I might not necessarily know exactly how high they will grow, but I could probably predict which one will grow the tallest and which one will grow the shortest. So, in that case, if that's my predicted outcome, what specific independent variable will I want to choose? Well, let's say I want to predict which one will grow the tallest. Well, maybe I actually think Coke will, because maybe the Coca-Cola has some kind of nutrients, some sugars and things like that the plant might grow really, really tall in. So maybe that's what I would predict to grow the tallest. Okay, so the Coke will, and then what's my predicted outcome? Well, will make the plant grow the tallest. And often it can be helpful in this type of question to actually do the opposite. Okay, so if Coke will make the plant grow the tallest, which one will make it grow the shortest? Well, maybe I think water will do it. Okay, so then the water will make the plant grow the shortest. So with a qualitative independent variable, we want to predict some specific outcome. Okay, which independent variable will grow the tallest? Which independent variable will grow the shortest? Those are some specific outcomes. Whereas when we have numbers, well, then we can follow a different formula, which just basically says, as your independent variable increases or decreases, your choice, the dependent variable will increase or decrease, again, your choice. It's very formulaic, it's very plug and play.